Welcome to the Deep Dive. We take fascinating sources, dig through them, and pull out the most important insights for you. And today, wow, we're diving into the world of M.C. Escher. I mean, just captivating stuff. You know his work, those impossible staircases, structures that seem to twist reality depending on how you look at them. They just defy logic. These things have fascinated us for, well, decades, but they've been a huge headache for digital artists.
Oh, absolutely. A massive challenge. Until now, trying to, translate these illusions into digital 3D space, it's been incredibly hard. Because traditional 3D modeling, it fundamentally breaks the spell.
Right.
It tries to force this impossible object into regular geometry and oof, the trick is revealed. The magic just collapses.
And that is exactly where we're jumping in. Today, we're looking at this really groundbreaking solution. It's from MIT's Computer Science and Artificial Intelligence Lab, CSL. It's called Meshers.
Meshers, yeah.
And this software, it seems revolutionary. It apparently cracks the code on these impossible objects because it sort of thinks like the human brain does.
That's a great way to put it.
Freeing up digital art from, physical rules and even giving scientists maybe a new way to look at perception itself.
Exactly. It's potentially a huge deal for both art and science.
Okay, so let's get into it. Why didn't the old ways work? You touched on it, but let's unpack that.
Sure. So previous digital methods, they always involved these big compromises. Imagine trying to build, say, a Penrose triangle in just a standard 3D program.
Yeah.
You'd literally have to cut things or bend them or position shapes at these very precise, often really weird angles just to make it look right from one viewpoint.
Like a cheat, basically.
Totally cheat. And the second an artist tried to adjust anything, maybe the lighting or make the object smoother,
It falls apart.
the whole illusion just shatters instantly. And it wasn't just about looks either. These workarounds made any real geometric analysis, any calculation, completely impossible.
So it wasn't just an aesthetic problem, it was fundamentally mathematical, too. You couldn't actually do anything meaningful with these broken illusions.
Precise.
But Meshers, you said it takes a radical approach. It doesn't force things into 3D. So what's the secret? How does it keep the illusion intact?
Yeah, that's the core innovation, really. Meshers works in what the researchers call 2.5 dimensions.
2.5 dimensions. Okay, what does that mean?
It's a little tricky to wrap your head around, but basically it captures the X and Y coordinates, the flat image.
Right, like a picture.
Like a picture, yes. But critically, it also captures the apparent depth differences between pixels right next to each other. Think about how even in a flat drawing, your eye sees one line as being in front of another.
Okay, yeah.
It's mapping that perception, the illusion itself, rather than trying to force it into a true, physically possible 3D model.
Huh. So it's not building an impossible object in a possible space. It's working directly with the illusion as our eyes perceive it.
Exactly right. And this lets the tool, as they put it, reason about impossible objects without forcing them into conventional 3D space. It's not trying to jam this square peg into a round 3D hole.
That makes sense.
Anna Dodick, who's leading this work, she said it beautifully, Meshers has potentially unlocked a new class of shapes for artists to work with on the computer. And beyond art, she also mentioned it could help perception scientists understand the point at which an object truly becomes impossible.
Wow. So it's not just about cool graphics. It's digging into how we actually perceive reality, or unreality, I guess.
Yeah, it bridges that gap.
And you mentioned perception.
Yeah.
That brings us to what sounds like the real genius here. How it mimics the human brain.
Okay.
Let's use that Penrose triangle again.
Okay.
When you look at it, right, each individual corner, each little segment looks totally fine. Plausible. Our brains make sense of those bits in isolation. That's local consistency, is that the term?
That's the term, yes. Local consistency. Each part looks okay on its own.
Right.
But yeah, try to follow it around, put those locally consistent pieces together globally, and the whole thing just breaks physics. It cannot exist in our physical world.
Right.
And the breakthrough with Meshers is that it computationally preserves those locally consistent areas without demanding that the whole thing makes sense globally. It behaves like our brains do when we look at these illusions. It accepts the parts without insisting the whole fits together physically.
So Meshers isn't just copying the look. It's actually replicating, computationally, the cognitive process of seeing something impossible. That's really fascinating.
It really is.
Okay, so clearly this isn't just about making neat, tricky pictures. It opens doors for art and science.
Yeah.
But how practical is it? What can Meshers actually do beyond generating these images.
Oh, it goes way beyond just generating images. The researchers showed some really compelling applications, things you might not even expect.
Like what?
Well, for instance, scientists can actually use measures to calculate geodesic distances across these impossible surfaces.
Geodesic distances, like the shortest path.
Exactly. They gave this vivid example of tracking like an ant's path crawling across an impossible...
An impossible layer. I love it.
Right. An object that has physically paradoxical shading, yet you can still calculate paths on its surface within the tool.
So you're running simulations, basically, on shapes that literally cannot exist in reality. It's like a scientific playground for paradoxes.
That's a perfect way to describe it. And you can even model things like heat diffusion across these weird structures, see how heat might spread on a surface that doesn't follow normal rules.
That's wild.
Yeah.
And what about for the artists? What kind of control do they get?
The control sounds amazing, actually. You can adjust the lighting, say, create a sunrise effect or a sunset mood, and the illusion stays perfectly intact. It doesn't break.
Okay, that's key.
Absolutely. And you can do precision editing, too. They showed an example where they could subdivide parts of the structure for really detailed changes, like refining a red heart outline drawn onto an impossible shape. Justin Solomon, who's a senior author on the paper, he pointed out that this shows how computer graphics tools don't have to be constrained by the rules of physical reality. He says it lets artists reason about shapes that we will never find in the real world.
That's a pretty powerful idea, redefining digital reality.
It really is, thinking beyond physical limits. And I heard something about converting existing art.
Yes, that's another incredibly exciting part. Meshers can actually take existing 2D artwork drawings, images of impossible objects, and convert them into these manipulable digital forms.
How does it do that?
They use techniques called inverse rendering.
Inverse rendering. Okay, briefly, what's that?
So normal rendering takes a 3D model and creates a 2D image, right?
Right.
Inverse rendering does the opposite. It takes the flat 2D drawing and intelligently sort of reconstructs the underlying 2.5D impossible structure from it. It infers the depth relationships needed to keep the illusion working.
Whoa. So you could potentially take a classic Escher print, scan it, feed it into Meshers.
And suddenly it's this dynamic, editable, digital object. The flexibility sounds incredible.
It really does. They tested it on all sorts of things, architectural impossibilities like weird windows and buildings, but also more whimsical stuff like a dog riding a skateboard.
Seriously, a dog on a skateboard.
Apparently so. And in every case, the software kept the mind-bending properties intact even when they changed the lighting around. It's like taking pure imagination and making it digitally real and workable.
That's just amazing. So what's the future here? What's next for Meshers in this kind of digital creation?
Well, the team definitely has big plans. They want to create a more user-friendly interface, obviously, to get it into the hands of more artists and designers, make it more accessible.
That makes sense.
And they're also working on tools to help build even more complex, elaborate, impossible scenes from scratch. Plus, they're keen to collaborate more closely with perception scientists to really dig into those broader applications we talked about.
And it's worth pointing out, this wasn't just a couple of people in a basement.
Yeah.
This involved multiple MIT departments.
Right.
And support from big names.
Oh, yeah. Huge collaboration. Support from the National Science Foundation, Google, Adobe Systems, even various defense and intelligence agencies. It's a major effort.
So summing it up, Meshers feels like much more than just a clever piece of tech.
Absolutely. It feels like a real paradigm shift, potentially, in how we think about digital art and even geometry. It sort of unhooks computer graphics from strict physical reality. It empowers artists to explore things that were previously just, in their heads or on paper. And like we said, it gives scientists totally new ways to study perception.
So as we wrap this deep dive, the big takeaway seems to be that Meshers lets us digitally create, manipulate, and even analyze impossible objects by mimicking how you perceive them. It takes the fantastical and makes it digitally tangible, editable, even measurable.
And that loops back perfectly to Anna Dodek's vision, doesn't it? That idea of shifting the question from, is it possible, to what if it were? Meshers is proof of what can happen when our technology starts to catch up with our imagination. It really makes you wonder.
Yeah.
What other impossible boundaries are out there, in fields you care about? What limits are just waiting for a breakthrough like this now that we're seeing tools push past what we thought was digitally possible?
That's a fantastic thought to end on. Challenging those fundamental assumptions, like the rules of geometry, can lead to incredible places. A truly brilliant deep dive. Thank you.